So we got caught off at the end there. So I just wanted to say that we would have had 21.0 after we multiplied by 47. Okay. Now, last 4 questions we have from review 1. Write the log equation as an exponential equation. You do not need to solve for x. So for 9 here, remember we're talking about log bay, but something's different about this one, right? There's no small base that's shown. If there's no small base shown, remember we assume that the base is 10. So if it's not there, we assume it's 10. So if I'm going to convert log bay into exponential, we want to put it back to a base to an exponent equals the answer. So the base would be 10. The exponent would be 4 to the x, and it's equal to the answer of 5x minus 3. And we're going to stop right there. It did not tell me to solve. So that would just be our exponential equation. Okay. For 10, a quantity with an initial value of 410 decays exponentially at a rate of 75% every 8 days. What is the value of the quantity after 1 week to the nearest hundredth? So there's a couple of things we have to read carefully in there. So first off, my initial value is 410 and it's decaying exponentially every 8 days. So that means we are doing the decay formula, but t is not going to be in years this time because it says every 8 days. So we're going to make t be in the unit of days. We know the initial amount was 410. We're doing 1 subtract 0.75 t divided by 8. So now my unit t is in days. What is the quantity 1 week after? So we have to think about how many days are in a week. We're going to plug in 7 here. Okay, 7 days in 1 week. And then everything else just plugs right into the calculator now. So to get this, I go right into my calculator and say 410. 1 subtract 0.75 is going to be 0.25 raised to the 7 divided by 8. And we let the calculator do this. To the nearest hundredth, we're looking at 121.89. Okay, algebraically solve. In this case, I can't plug this into the calculator right now because I have x's on the left side here. So we're going to take log bay and rewrite it. Okay, so we know that this is our log bay. The base then is x plus 3. My answer is going to be the 1 over 32, where the exponent is my negative 5 over 4. I'm just going to write it so I have a little bit more room. Now, before I can do anything, to get rid of this exponent, we know how to handle that. We saw it in the first video. We raise it to the reciprocal, negative 4/5. Okay, so on the left side, this just cancels down to x plus 3. On the right side, we're going to let the calculator do it. So just so you can see what I'm talking about from before, remember we can use alpha y equals 1 over 32. Make sure we're raising this, not multiplying, to the negative 4 divided by 5. Or you could do alpha window again. But we get 16. So we let the calculator handle that for us. And then when we subtract both sides by 3, x equals 13. Last one here, Oliver invested $9,200 in an account, paying an interest rate of 4.8%, compounded continuously. Assuming no deposits or withdrawals are made, how much money to the nearest cent would be in the account after 18 years? Remember, this is a phrase we care a lot about here. That changes our formula. Compounded continuously is a PERT. So we're trying to find out our total. If we started with 9,200, E, we plug in as normal, 0.048 is the rate, and we're giving it 18 years here. So we want to know to the nearest cent. I'm just going to plug that right into the calculator. 9,200 E raised to the 0.048 times 18. Okay, so we're looking at 21,828 and 22 cents. So that's just a little overview of everything from Review 1. Check out the video for Review 2, and then keep in mind that our quarterly is going to be due at the end of this week.